In your opinion, Professor, what are the most compelling pieces of evidence we currently have for alien life, and why do you think the scientific community remains skeptical?
Without seeking the evidence, we will never know. And so the problem in scientific inquiry is that very often scientists assume the answer in advance or claim that uh, uh, it is an extraordinary claim that requires extraordinary evidence. But because life is very often a self-fulfilling prophecy, they're not seeking the evidence because they regard it as extraordinary. And as a result, we don't find the evidence. And my point is that it's not an extraordinary claim because we know that we exist on this planet called Earth, near a star like the sun. And we know, based on the latest data, that there should be of order 100 billion Earth-Sun systems at roughly the same separation, so that if the planet has an atmosphere, it could have liquid water on the surface and the chemistry of life as we know it. And moreover, most of these stars formed billions of years before the sun. And so it's actually a completely ordinary claim to argue that something like us may have existed billions of years ago. It's actually arrogant and extraordinary to claim that we are unique and special and there is nothing like us under similar circumstances in 100 billion other systems within the Milky Way galaxy alone. And there are a trillion galaxies like the Milky Way in the entire universe. Now you may say, okay, well, we could search for microbes, and that's actually the approach taken by astrobiologists. They're willing to invest more than $10 billion in the Habitable World Observatory planned for 2040 or later. And that is the highest priority that was defined in the decadal survey of the astronomy community this decade. Of course, Earth may have developed microbial life as soon as it cooled, but it's very difficult to find evidence for microbial life. We can either find it by going places like within the solar system, going to Mars and checking the soil, or looking under the ice for any microbes in the liquid water that is on moons like Enceladus or Europa. But another approach is to check the composition of the atmosphere of exoplanets. And we can do that by monitoring as they pass in front of their host star, monitoring the light that goes through the atmosphere and looking for the fingerprints of those molecules that on Earth were produced by life, such as methane, oxygen, and if we find those molecules, it will not be conclusive that they resulted from life, because you can have geological processes that potentially, naturally, would produce some of these molecules without having life. On the other hand, even though intelligent life came to Earth just over the past few million years in the form of humans, the signatures are much more robust, because if we find a gadget that was manufactured by another civilization near Earth, it will be not only evidence for life, but evidence for intelligent life. And it's much clearer, a much clearer signature. We can look for industrial pollution in the atmospheres of planets. We can look for city lights. These are subjects that I wrote papers on. But in the past, over the past 70 years, a small minority of the scientific community that was sort of put in the periphery of all funding agencies involved searching for radio signals, because we transmitted radio signals. And so the idea was, let's check if there are any transmissions from other civilizations near other stars. But this is just like waiting for a phone call at home. Nobody may call you when you're waiting. The approach that I'm suggesting, alternative to that, is to search for technological objects, because we did launch probes that will exit the solar system, go to interstellar space. We are polluting space with space trash. In fact, around the Earth right now, there are plenty of broken pieces of satellites and other debris. And just imagine in a billion years when the sun would brighten up, it will produce enough radiation to and there will be enough material carried by the wind coming from the sun as it evolves to a red giant, so that all this debris will be swept into interstellar space. So even the space trash that surrounds the Earth would eventually make it because of the evolution of the sun. And so since most of the stars formed billions of years before the sun, it could have been that other technological civilizations are not alive anymore. They will not transmit any. Most of them are dead, just like most of the 117 billion people that lived on Earth are not alive anymore. But we can look for relics that they left behind, and in the form of space trash, in the forms of functional devices, gadgets that we might find. And that kind of a study was not done. And all I'm saying is we should invest at least a few $billion in that because we want to hedge our bets. And without searching for those things, we cannot say anything. And so, recently, a couple of months ago, I placed a bet against Elon Musk. I heard Peter Thiel saying on a podcast after the elections that nobody should bet against Elon Musk. And so the following day, I placed a bet in an essay that I published on medium.com. And in the bet, I basically said I'm willing to put 1% of my net worth against 1% of Elon Musk's net worth, which would be $4 billion for him. And let's put it in a pool that will be allocated to the search for extraterrestrial civilizations, because he said that we're probably alone. And I'm saying, no, we're probably, there were plenty of students in our class, and we're probably in the middle of the class in terms of our abilities, and there were much more advanced technological civilizations. We just need to search for them. We haven't done that. So with this central pool of funds, I suggest we will search for those technological gadgets. And if within a decade we don't find them, I'm willing to put another 1% of my net worth and give it to Elon Musk as a gift. I haven't heard from him, but my point is that scientific projects of this great importance were funded at $10 billion in the past, like the Large Hadron Collider, the Webb Telescope. And this question of whether we are alone, whether there are neighbors out there that we can learn from, is extremely interesting to the public. And so it would make a lot of sense for science to address this question using the tools that we have. And I have a very clear agenda of how to advance our knowledge on this question. New knowledge doesn't fall into our lap. We really have to invest time, effort, and money. And for example, we search for the dark matter, for maybe 50 years now. That's 85% of the matter in the universe. We have no idea what its nature is, and we haven't found it. And the Large Hadron Collider was supposed to perhaps find hints for it. It didn't find any. And so that's not a failure. That's the way science is done. But what I'm saying is, even if we don't find the dark matter, nobody regrets investing billions of dollars in the search. So on a question that much more appeals to the public, I think we should definitely spend this money before we say that it's an extraordinary claim to think that we are unique, that we are not unique and special.